This question is the 2016 Ordinary Level question C1 looking at geologic geometry. This map is located on the back of the section A's, and the question then is found in the exam paper in section C. So the question, the accompanying map, shows ground contours at 5 meter vertical intervals, so 30, 25, 20 and so on. Part A, on the drawing supplied, draw a vertical section profile on the line AB. So we're asked to draw a profile along this line here. We'll use this space up here up on top. Part B then of the question, CD is the centre line of a proposed roadway which is level at an altitude of 35 metres. Using side slopes of 1 and 1 for both the embankment and the cuttings, complete the earthworks on the northern side which are necessary to accommodate the roadway. So we're going to use side slopes of 1 and 1 for both, which is going to make it nice and easy for us. And we're just doing the northern side, this part of it, this side of it's already done. First, what we're going to do is just kind of have a look at this section up here. So the profile, I'm just going to adjust the video and zoom in on that. So as starting with all of these questions, when we're dealing with our profile, we're looking for the heights between A and B. And what we're going to do first is we're going to find the lowest point and the highest point. So the lowest point is 15, there's no contour that's lower than that, and the highest point is 50, there's no point that's higher than that, so there's two 50s there. So we're going to take each of these heights, I'm going to find height lines, corresponding height lines up here for each of these, and so they're all 5 meter intervals, so that's 5 millimeter distances that we're going to use up here. So 15, 20, 25, 30, 35, 40, 45, 50, yeah. So I'm leaving just a small bit of space. I'm not going to put my lowest point 15 down here on the bottom one, and I'll show why in a moment. So each of our lines here, they're 5 meter intervals, each one get higher than the last. They're 5 meter intervals because that's what the map says, 5 meter contours, so we're going to use 5 millimeter intervals for drawing these lines here. So this is 15, 20, 25, 30, 35, 40, 45 and 50. There's the top point. Each time that a contour hits through, goes through our line AB, we're going to project that up into the profile view. So point A is first, that's at an altitude of 40. So where that hits our 40 height line up here is this point. That's point A, and then we're going to do this for each of our lines along here now next. So the next one that it breaks through is 45, it cuts that through there. 50 next. Top 50 again. 45. So doing this each time that the line AB breaks through a contour, we find the corresponding height up in the elevation for that contour. So that was 35. This one is 30. We're going to bring that up to the 30 height line. So that's there. 30 height line is here. If you want, you could do your heights on both sides just to make it a bit easier, less likely to make a mistake. But one side works fine. So 15 and 15 again. And then finally point B is at a height of 20. Joining all of these points up now as best we can. It's a curve that we're going to be drawing. The best curve that we can, that'll touch off each of these points. And down here now is why I kept point 15 up off the bottom and I didn't put 15. So as we 15 here and here, our line isn't just going to go straight across there at 15. It's going to kind of come down a little bit below point 15 and then back up again. If I had put that onto the solid black line there at the bottom, I wouldn't really be able to draw that. It would be coming down into it. So if you have the space, which generally you will, it's good just to keep your first point. If your two lowest points are both 15, if there was only one 15 there, so it went 20, 15, 20 and back up again, then you could put it on the bottom line. But it's not a big deal. So this gives us enough space for this. So that's the first part of this question completed. That's part A. Second part of this question is doing the roadworks for the other part of the on the other part of the map. In the question, we're told the line CD, which is this one here to here, is the centre line of a proposed roadway. So on there, at an altitude of 35. So that 35 is important. Using side slopes of 1 and 1 for both the embankments and the cuttings, complete the earthworks on the northern side, which are necessary to accommodate the roadway. They've already completed the ones on the south side. So 35 is the height of the road. So what I'm going to do first is find all the 35 contours that the road crosses and mark a point on the side of the road. That's going to be a point where it's going to transition from a cut to an embankment. And I think that's the only one. Another way to tell is if you look on the south side of the map, it only the lines here only touch the side of the road once. So there's only one transition between a cut and an embankment. Side slopes of 1 and 1 for both the cutting and the embankment means we can just use the same lines going along the side here. For every 5 meters, so this is going to be over here, this is going to be a cut because it's higher. So 35 is here, all these contours are higher. So 35, 40, 45, 50, they're all higher on this side. This side they're lower, so this is going to be an embankment building it up. This is a cut. Now as they're all the same, it's 5 meters out. So here for every 5 meters that we're going up, we're pushing the ground back 5 meters as well. So just on this section here, I'm just doing contour lines, or height lines that'll correspond to some of our contour lines. So these ones here, 35 is the side of the road, 40, 45, 50. I've gone too far out. In each place that a contour line intersects the same height line is a point on our cut. So 35 hits the side of the road here. The 40 contour hits the 40 height line at this point. It hits the 45 contour hits the 45 height line here. Same for the 50 and the 50 again, and back down to the 45. So I've got too much height up there. That's this side. This is where we're cutting the ground back. Just a water pipe, water flowing downhill. On this side, it's the same idea. Our numbers are going to be going the opposite way. So instead of it'll be still 35 at the side of the road, because the road's still at the same level, and then it'll be going downhill after that. So I'm going to use the same lines here. I'm just going to put them in a different color so that we know which ones are cuts and which are embankments. So again, 35 is the side of the road. This time it's going down 30, 25, 20, and down to 15. So again, each place, this point we already have, each place that a contour of a specific height hits the height line of the same height is a point on our embankment. So the 30 height line here hits the 30 30 contour hits the 30 height line here. 25 contour hits the 25 height line, 20, 15, 15, back up to 20, 25, 30, 30 again, back down to 25, 20, 15, and sorry, there's a 10 over here that I didn't see. So we just need to go out one more. So that there is 10 meters. And that is at this point here. So our contour or embankment is going to look something like this. Join up all the points. So hitting each point out through each one there. And that completes this question, 2016 Ordinary Level Question C1.